Hi dear students, let's see this question that came in KVPY 2018 SX Part 2 Physics paper. This is a question of motion in vertical gravity, that's it. A very simple question, just that the language has been made slightly difficult, but overall the question is very easy. Over here, let's see what's happening. A spiral galaxy can be approximated as an infinitesimally thin disk, which means that let's assume this to be a spiral galaxy, okay, which will have some mass, so we can assume that this is a uniform disk. Okay, now what is happening is there are two stars which are being released from distance 2z0 and z0. That means, let's say first star is released from distance 2z0. Okay, so this is 2z0, and the second star, so this is star 1, and the second star, let's say, is released from this position, which is z0. Okay, so from this height z0 above the plane of the disk, so it is going to perform oscillations. Okay, so you have to compare the time period. That means we have to find the time period of oscillation 1 to time period of oscillation 2. We have to assume that disk is very large in comparison to z0. Correct. Now it's a very easy question, because we must realize that the gravitational field of a uniform disk is constant. Okay, because near the disk, the gravitational field can be considered as a constant. Okay, if you see that the formula of the gravitational field is nothing but sigma upon 2 epsilon naught into 1 minus cos theta. Now epsilon naught can be replaced by 1 by 4 pi k, so this will be 4 pi g, sorry, not 4 pi k, sigma upon 4 pi g into 2 into 1 minus cos theta. This is the value of the gravitational field. E represents the gravitational field. So if you have this type of disk, okay, so here, uh, at an angle theta, this will be the value of the gravitational field. Okay, but if we choose this point very close to the center, because this r is very large in comparison to this distance, so cos theta, we can say that approximately it will become 0, because theta will become pi by 2. So we can say that this electric field, sorry, this gravitational field will be constant. It will be independent of this theta, if theta is very close to, or if this point is very close to the center. So which is what is happening over here. Or we can also consider this disk as an infinite plane for points which are very close to the center, or the plane of the disk rather. Hence we can say that uh, we could have treated the gravitational field as constant. Now once we realize that we can treat this gravitational field as constant, so it's a very simple question, because we can say that acceleration of both of them will be same, because acceleration is nothing but mass of the star, okay, into the gravitational field. E represents the gravitational field divided by the mass. This will be the force upon mass. So we can say that acceleration of both the stars will be E only. So if you consider any of the star, it will go like this, hit the plane with a very high velocity, then it will go on the other side and it will retard. Okay, because the gravitational attraction will again try to decrease the velocity. It will again come back and will again go here and stop, and again it will keep on oscillating like this. So we can say that total time period will be nothing but the 4 times of time from this point to this point. That means from the extreme position to the plane of the disk. टाइम पीरियड कितना, मतलब टोटल टाइम कितना होगा, यहाँ से यहाँ तक का टाइम निकाल के 4 से मल्टीप्लाई कर देंगे. करेक्ट. तो ये टाइम इज वेरी सिंपल, विच वी कैन से दैट कितना आएगा, √2h अपॉन, मतलब इस हाइट को अगर अपन h कह रहे हैं, √2 हाइट अपॉन एक्सेलरेशन. करेक्ट, because you can use the formula of gravity only. So 2 root of 2h upon a ये आ जाएगा, right? तो if you see t1 to t2, so basically मतलब जो फर्स्ट स्टार है that उसकी हाइट 2z0 है, और जो सेकंड स्टार है उसकी हाइट z0 है. So everything will cancel out. We can say that the answer will be twice of 2z0, twice of 2z0, okay, divide by 2z0. Correct. So what do we get? √2. T1 is to T2 is to √2. Very simple question. Vertical gravity का question, and that's it. I hope you would have understood. Thank you.